So this video is for integrated 3. This is for the chapter 4 classwork / homework number 3. So all of these on numbers 1 through 10 are dealing with a standard normal curve. And the standard normal curve is what I drew right here, where you have 0. Let me get this so you can see. Where you have 0 as your mean, and each standard deviation is actually 1 unit. Okay, so it goes 1, 2, 3, -1, -2, -3. That's what all of 1 through 10 is. Okay, the ones after that are a normal curve. When I don't use the word standard, standard means that your mean is 0 and your standard deviation goes by 1s. When I don't say the word standard, I just say normal, as I would be talking about down here. These ones, the mean is not 0 and the standard deviation may not be 1. Okay, but we still use the normal curve and the normal distribution. So the first one I set up here for you, if they want to see what the probability, that's what this P stands for, what's the probability that a value is between 0 and 3. Okay, I put 0 for my minimum, 3 for my maximum. All of these are going to have a a mean of 0 and a standard deviation of 1. Okay, and you can just leave it as the 0.4987 since it is a probability. You don't have to give it as a percent. I just showed you that this is what it is, a probability, and this is what it would be as a percent. So in the next situation, if I was going to draw this, okay, again, our mean is 0, and I want the standard deviation to be greater than -1. So really that means I am looking for everything from here up forever. And so I am going to write that as normal CDF, lower bound -1, upper bound is infinity, which is 10 to the 99. My mean is 0 and my standard deviation is 1. And I'm going to put that in my calculator. And remember to put this in your calculator, second and the distributive button. And then I want number 2, normal CDF. And I'm going to put in a -1, 10 to the 99, 0, and 1. And that gives me 0.8413 as our answer. Now remember, the whole area under the curve is a 1. So 1/2 is 0.5, the other half is 0.5, so that's a reasonable answer. Okay, on the next one. Okay, again, my mean is 0, my standard deviation is 1, and I want it less than 2.2. Okay, so 2.2 somewhere on the side. I'm not being accurate with the length of that at all. Okay, so we're looking for that whole region right there. So I am going to type normal CDF. My minimum is -infinity, which is -10 to the 99, up to 2.2. Mean is 0, standard deviation is 1. So when I put that in, -10 to the 99, 2.2, and then my 0 and 1, I should be getting more than 50%, and you see I do. I actually get closer to almost the whole 1. I get 0.9861. I'd round it up to 1. On number 4, okay, 0. And again, I want a -0.6 to a positive 0.4. And I obviously didn't space that well. So I want this little section right here. And so I'm going to write normal CDF, -0.6 to 0.4, mean is 0, standard deviation is 1. And for that, okay, -0.6 up to 0.4 and 0, 1, I end up with a 0.312, 0.3812. 2. On number 5, 0, negative 2.8, 1.8, and I want all of that area here. So I am going to do normal CDF, negative 2.8 to 1.8, 0, 1. And let's see. So negative 2.8 to a positive 1.8. And I get a 0.9615 for that answer. Okay. On number 6, 0, negative 1.8 to 0.2. So normal CDF, minimum's negative 1.8, maximum is 0.2, mean is 0, standard deviation is 1. Oops, hold on. So negative 1.8 to 0.2 and 0 and 1. I end up with a 0.5433. On the next one, 0, negative 0.4, positive 1.6. Want everything in between here. So normal CDF, negative 0.4 to positive 1.6, mean 0, standard deviation 1. And so negative 0.4, 1.6, 0, and 1. And we get a 0.6006. Okay. 0, 1.6. Now in this case, I want everything greater than that. So I am going to write normal CDF. Minimum's 1.6. Maximum is going to be infinity, which is 10 to the 99 on the calculator. Mean 0, standard deviation 1. And when I put that in, I end up with a 0.0548. 0.0548. For 9, I want it greater than 2.8, so this is probably going to be a small number here. So normal CDF, 2.8 is minimum. The maximum or upper bound is infinity or 10 to the 99. Mean 0, standard deviation 1. Okay, and so 2.8, 10, oops, well, let me clear it. Start again. 2.8, 10 to the 99, 0, 1. And I get a 0.00 to 6. And the last one in this category, mean is 0. I want 0.8 and below. Should be more than 50%, so more than 0.5, but probably not too much more. So let's see, second and distributed for number 2. 0.8, negative 10. Hold on a second. Actually, let me write it out here. Maybe that will help me. So this is going to be, oops, that's highlight. This is going to be normal CDF. I need my lower bound first. So my lower bound is going to be 10 to the 99, because that's negative infinity, to 0.8, and then 0 and 1. Okay, so let me come up here. Negative 10 to the 99, 0.8, and then 0 and 1. And I get 0.7881. So we see it's more than 50%. Okay, this next section is going to be each one a totally different situation, okay? The first one, we're going to have a mean of 40, standard deviation of 2, and I want it greater than 42. So I'm going to do normal CDF. My minimum's 42. My maximum is infinity, or 10 to the 99. My mean is 40. My standard deviation's 2. Here, my mean is 40. My standard deviation is 2. And I'm going to put that into my calculator. Um, 42, 10 to the 99, 40, and 2. And I end up with 0.1587. Okay. On number 12. Okay, this time our mean is 90. Our standard deviation is 5. And I want it from 95 to 100. So we're going to go normal CDF. Minimum is 95, maximum's 100, mean is 90, standard deviation is 5. So 95, 100, 90, and 5. And we end up with a 0.1359. On number 13, mean is 75, standard deviation is 3. We want it less than 68 is what we want. Okay, so that's what I want. So this is going to be normal CDF. Minimum is negative 10 to the 99. The upper bound is going to be 68. The mean is 75. And the standard deviation is 3. So negative 10 to the 99, 68, 75, and 3. And we end up with 0.0098 as our answer. On 1478 is the mean. Standard deviation is 8. We want it between 68 and 96. Between 68 and 96. So this is what we're looking for, this shaded region. And so normal CDF, minimum 68, maximum 96, mean is 78, standard deviation is 8. So 68, 96, 78, and 8. And I get 0.8821 as our answer. Now, on the back side, okay, all of these problems, 15 to 18, are dealing with the same mean. So we've got a battery manufacturer that claims that the lifespan of batteries is normally distributed with a mean of 45 months and a standard deviation of 5 months. And so the first one, what is the probability that a particular battery is between 45 and 52 months? So my mean is 45, and we want to know if it's what's the probability that it's between 45 and 52. So we're looking right here. So normal CDF, minimum 45, maximum 52. Mean is 45, and the standard deviation is 5. So 45, 52, 45, 5. So we get 0.4192. On the next one, this is asking us the percent, okay? So what percent of the batteries will have a lifespan between 48, now remember 45 is a mean, so we want between 48 and 50. So we want this little section right here. So I'm going to do normal CDF, minimum 48, maximum 50, mean 45, standard deviation 5. And let's see. So 48, 50, 45, and 5. So it's a 0.1156. So that's going to be 11.56% because they wanted this one as a percent. On number 17, if a battery contains 18 batteries, how many would you expect to have a lifespan of more than 54? So remember, 45s are mean. We want to have more than 54. Now we want to know how many out of 18. So first thing I need to do is find the percent. So I'm going to do normal CDF. 54, 10 to the 99, mean is 45, standard deviation is 5, and that's going to give me a probability or a percent, okay? So 54, 10 to the 99, 45, 5. And that's going to give me a 0.0359. I am going to take that and I'm going to take 0.0359, which is 3.59%, times it by 18 to see what I get. And so when I times this by 18, I end up with 0.6467. Okay, so not even one battery will end up being that lifespan. Okay, on the next one, if a package of batteries contains 24 batteries, how many would you expect to have a lifespan between 37 and 56? So the mean is 45 still. Between 37 and 56 is what we're looking for. And so the normal CDF, 37.56, mean is 45, standard deviation is 5. Okay, so let me just put this in, 37.56, 45, 5. 93.13%, so 93%. And so I'm going to take that 0.313, which is 93%, and times it by 24 batteries to see how many. So times it by 24, and we get about 22. Okay, so about 22 batteries. This one here might round up to about a 1, but no more than that. Okay, so let's take a look at these ones down here. So now these ones are going to be slightly different. In this case, to qualify as a contestant in a race, a runner has to be in the top 16%. The running times are normally distributed with a mean of 63 and a standard deviation of 4. Okay, so a mean of 63 and a standard deviation of 4. And we want to be in the top 16%. So if we're in the top 16%, we're actually looking for this bottom 16 because you want to be fastest. So we want smaller numbers, not bigger numbers. So 63 is a time. Okay. 63 minutes, I guess. You want it to be less than 63 if mean is 63. And so when I'm doing this, I'm going to be doing the inverse norm because I want to find the value. I want to find this value. What is that x? So I'm going to do inverse norm. And when I do the inverse norm, I'm going to be wanting 16%. That's my area. My mean is 63. My standard deviation is 4. And this is going to give me back the value. So I do second and distributive, and I want number 3 this time. Okay. And the area is the 0.16, which is 16%. My mean is 63, and my standard deviation is 4. And I end up with 59.022. They want to the nearest minute. So to the nearest minute, it's 59 minutes. Okay, on the next one, every year the top 8% of the graduating seniors get awards. The grades of the graduates are normally distributed with a mean of 85 and a standard deviation of 6. Now, in this case, if my mean is 85, I want to figure out where would it be so that the top 8%. So in this case, I'm over here. This is going to be 0.08. Now, if I'm finding 0.08, I'm really trying to find all of this is the area to get up to that. So when I'm trying to find this value x, this is going to be 0.92 area because the other part is going to be the top 8%. Okay, we have 92% below us if we're in the top 8%. So I'm going to go inverse norm, inverse norm. The area I'm looking for is 0.92 because I want to have 92% below me. My mean is 85, and my standard deviation they gave us here, the standard deviation was 6. Put that into my calculator. And I'm going to put in a 0.92, 85, and 6. And I get a 93.43. They want to the nearest hundredth. Okay, so that is the percent or the score. I'm not sure if it's as a percent, but that is the score. Okay, the last one here. Gail and George each took the same standardized exam, but two different groups of students each scored 83. Okay, in Gail's group, the mean was 78 and the standard deviation was 6. In George's group, the mean was 74 and the standard deviation was 4. Determine whether Gail or George, if either, is in the top 10% of their group. So for Gail, 78 was the mean and the standard deviation was 6. So 78 and the standard deviation was 6. So let me just put that here. The standard deviation is 6. Okay, now she scored an 83. They both scored an 83, and we want to see if that puts them in the top 10%. So if this is the top 10, that means the rest of this is 90%. And let me draw a situation for George. So George's group, the mean is 74 and the standard deviation is 4. So his standard deviation is 4. His mean is 74, so the mean's lower. We want it to still be in the top 10. Okay, so we still want to be in the top 10, which means this is going to be 90% below them. And what we're looking for again is the score. I want this score. What score do they need to get? Because they both scored an 83. So let me do Gail. So inverse norm, 0.9, because I want 90% below. Mean is 78 and the standard deviation was 6. And then I'm going to do George. Inverse norm. Again, area is 0.9. Area is 0.9. Standard deviation was 74 and the mean was 4. So let's see. Sorry, I pushed the wrong button. Okay, I want number 3. And so a 0.9, 78 and 6. So for Gail, she needed to score an 85.68 to be there. So Gail is a no. Not top 10%. Okay, and then we are going to do George. And we still want 0.9, but his mean was a 74 and his standard deviation was 4. And so in his group, 79%, or a score of 79.13 would have been acceptable. So that means George is in the top 10 because he scored, both of them scored 83. 83 for her would not put her in the top 10. 83 for him would put him in the top 10. And that's the end of this video.